Section 6.2 will look at graphing exponential functions. That means our base of our exponential will be a number of some kind, and then our exponent will actually be the variable, the x. Well, let's take a look at this first example for an exponential function. In this first one, we have y equals 3 to the x. So in order to graph this, let's assume we don't know what it looks like. Let's plug in a few values for x and see what we get out for y. And let's plot those points. So let's try a couple out here. Let's first try plugging in the value 0. Well, if you plug in 0 for x, we'll get 3 to the 0, which is just 1. So that's the point 0, 1, which is here. Now let's try another value that we'll plug in. Let's plug in 1. Well, then we'll get 3 to the first power, which is just 3. So that means if we plug in 1, we get out 1, 2, 3. So that's the point 1, 3 here. Let's keep going. Let's also plug in a negative 1. So 3 to the negative 1 means, remember, negative exponents flip down to the denominator, and you'll get 3 to the first on the bottom with a 1 on top, which means you're getting 1/3, which is about 0.33. So if you plug in negative 1/3, you get about 0.33. So we'll go ahead and graph that. And you can keep on going by graphing things like what happens at 2 and what happens at, let's say, negative 2. Well, at negative 2, you'd get 3 to the negative second, which would be 1/3 squared, because, again, the negative exponent would drop down to the bottom, which gets you 1/9, which gets you 0.11, which is even smaller. So you'll get smaller and smaller values as you keep on going. So our exponential graph here will look something like this. And what you'll notice here is that we're getting closer and closer to 0 without ever actually touching it, which means we have an asymptote here. So I'm going to draw it in as a dotted line, and this is called an asymptote. Specifically, it's a horizontal line, so it's a horizontal asymptote. And the equation for this horizontal asymptote is y equals 0. So notice that going towards negative infinity, we'll get closer and closer to 0 without ever touching it. As we go to the right, though, we get bigger and bigger and go up towards infinity. Now let's do the same thing for our graph B. Well, for our graph B, so we'll do the same thing. We'll plug in some x's and see what we get out for y. Let's plug in some similar values. So let's start out by plugging in 0. So again, 1/3 or anything raised to the 0 will still just be 1. So 0, 1 will be the point that we start out with again. What else happens? Well, let's plug in positive 1. Well, plugging in positive 1 gets us 1/3 to the 1, which is 1/3. So that gets us out, if you go over to 1, about 1/3. Now let's plug in, let's see, 2. If you plug in 2, get 1/3 squared, which is 1/9, which is about, again, 0.11, which is even smaller, but this time we plugged in positive 2 to get that value. Now what happens if we plug in a negative 1? Well, let's see, 1/3 to the negative 1. Well, negative exponent on a fraction will flip the entire fraction, so that will turn into a 3, or 3/1, and it will go to the positive first power once you do the flipping of the fraction. Well, 3 to the first is just 3, so if we plug in a negative 1, like we did here, we'll get out 1, 2, 3. So it's going to look very similar to the graph we just did, kind of just in the reverse direction. We get closer to 0 as we get further to the right. Again, you won't actually touch it, but you'll get closer and closer to 0, which means, again, you will still have a horizontal asymptote here at y equals 0. But it will just be that you're getting closer to the asymptote on the right side of the graph, not on the left side like before. And again, notice on the left-hand side, you are going to go up towards positive infinity up there. So those are going to be our two different kinds of exponential graphs. The first one on the left is what we're going to see if our base for our exponential is bigger than 1. And remember, bases look like our number to the x power. Well, our base here was a 3. It was definitely bigger than 1. So we have this kind of shape where it is increasing. On the problem on the left, we're looking at a problem where our base on our exponential graph is less than 1. We have a b to the x where the base b is less than 1. That's why we have a fraction like this. We have a fraction of 1/3. Means your base is less than 1. And that's why we got an exponential graph that is decreasing, because the base is less than 1. However, notice the one thing that these two graphs do share, actually two things that these graphs do share, is they both share the point 0, 1, because anything raised to the 0 is 1, and they both share the same horizontal asymptote at y equals 0. The only difference between the two is whether or not they are really increasing or decreasing as they go through that point 0, 1 and as they get closer to their asymptote. So when we graph our exponential functions, I'm really looking for three things. Where is that 0, 1 point? Where is our horizontal asymptote? And is the graph increasing or is the graph decreasing?